Well, hello. We should be recording at this point. This is going to be a discussion on the equations of motion. Before we get started, just the idea here is I'm going to be showing you how to derive 4 equations. You will not be responsible for repeating these mathematics, but I want you to see where these equations come from. So I want you to have some sort of basic idea of how this works, but I'm not going to have you on a test reproduce these particular mathematics, okay? Secondly, these 4 equations are going to be a way for us to relate 5 of our kinematic variables. Kinematics is what we're doing right now, the idea of the metrics of kinetics, motion. So the variables we have are v final, v initial, we have acceleration, we have displacement, those are our vectors, and we have time. That gives us 5 variables. And the 4 equations I'm about to show you are a way of showing the interrelationship between all 5 of these variables. Now, before we get started, these equations can only be used in a couple of contexts. One context is that the acceleration is constant, meaning the acceleration has to remain the same for the whole time. If it's 5 meters per second squared, it stays 5 meters per second squared. The other thing we're going to do is assume that the acceleration is not 0. In other words, these are equations of motion assuming accelerated motion. If you're not accelerating, then the equations I'm about to show you do not apply. For the case where the acceleration equals 0, you use the equation v equals displacement over time. If there is no acceleration, that equation, velocity is displacement over time, completely describes motion. If the acceleration is not 0, if the acceleration is some other value, then this equation does not count if the acceleration is not 0. This equation is for the acceleration equals 0 only. I'm about to show you 4 equations you can use under these circumstances. The acceleration is constant and it is not 0. So without ado further, let's start. By the way, brace yourself, this is going to be fairly mathy. Equation number 1. Let's start off with the definition of acceleration. Acceleration is a change in velocity over time. That means that acceleration is going to be our final velocity minus our initial velocity over time. So that means that the final velocity could be said to equal the initial velocity plus the acceleration times the time. I just solved that equation for final velocity. And we have equation numero 1. Yay! Moving on to equation number 2. For equation number 2, we're going to start off with the definition of average velocity. There is our equation for average velocity. And I do want to point out now that, well, there is another definition of average, right? I mean, average also means add them all up and divide by the number. If you've got 2 things, you add the 2 things together and then divide by 2 and you get the average. Which means average velocity could also, just by the definition of average, be the final velocity plus the initial velocity divided by 2, right? That's also how an average works. Well, that means that this has to equal this because they're both the average velocity. So I'm just going to set that equal to that. So delta x over t would equal v final plus v initial over 2. Clean this up a little bit. We have delta x is going to equal t, I'm going to move over here. So it's going to be 1/2. There's my 1/2 right here. Times v final plus v initial. So I've just taken this and rewritten it with the 1/2 out in front. And then the t comes over and we get t. And these are little vectors. That is my second equation of motion. Yay, progress. Number 3. For number 3, I'm going to start off with the previous equation. For number 3, I'm going to start off with this equation. So delta x equals 1/2 v final plus v initial times t. Okay? The next thing I'm going to do is I'm going to make a substitution. I'm going to substitute for v final. And I'm going to find a thing to substitute from v final right here. I'm going to take equation 1 and substitute that for v final. So that's this part right here. So delta x equals 1/2. I'm going to use square brackets to show what I substituted. V initial plus AT plus V initial T. So you can see that I took this variable and I substituted in this for it. Okay? And I forgot that. Well, let's do a little bit of work on this. For example, let's look inside that parentheses, I guess, is the way to do it. So 1/2, we have a V initial plus a V initial, so that's going to give us 2V initial. That leaves us with our AT. So it's going to be plus AT times T. Let's keep going. That gives us displacement is, I'm going to multiply everything through by 1/2. So 1/2 times this gives me V initial. At the same time, I'm going to multiply everything by T. So I'm going to multiply that by T. So I got the 1/2 times it, now the T. Oh, excuse me. Don't worry, I coughed into my elbow. So there's that. That leaves me this term. So 1/2 times this guy plus 1/2 AT. And then I also have to remember to multiply him by T as well. So T squared. This gives me my third equation of motion. And it looks like I forgot that vector guy again. And I forgot that vector guy, which goes on him there. Okay. So, 3 equations of motion now. Let's look at the 4th equation of motion. Number 4. I'm going to start off with that second equation again. So displacement equals 1/2 V final plus V initial T. This time I'm going to substitute for T. Last time I substituted here. This time I'm going to substitute for T. So let's write this out and get ready to substitute. So 1/2 V final plus V initial, and here's my square bracket ready to substitute for T. Now what am I going to substitute for T? Well, I'm going to come all the way back here and I'm going to take this equation and I'm going to solve it for T. So that would be V final minus V initial divided by A is T. So I took my V initial, subtracted it over, Then I divided everything by a, and that left me with the value for t. Cool. So I am going to substitute all of this. So v final minus v initial over a, and there's my substitution for t. The next thing I want to do is multiply all of this through all of this, multiply through by the half. I am going to shorten the algebra by doing it this way. And we would end up with v final squared equals v naught squared plus 2a delta x. All right, oops. This would be my fourth kinematic equation. So now I have 4. A comment or two about this equation. All right, a comment or two about this equation. I did not put a vector symbol over either of these two guys. Wait a minute, that's a horrible I. I did not put a vector symbol over these two guys. That's because both of them are squared. When you square a vector, you lose all information about direction. I'll give you an example. Just to make up a number here. What is -4 squared? Well, that is 16. So I have taken my vector and squared it, and I now got 16, okay? Now, let's unsquare it. What is the square root of 16? Well, that equals positive or -4. Agreed? Notice that when I squared my vector and then took the square root, I ended up with a positive or -4. If I were to be using this equation and I were to solve this for v final, I would be taking the square root of this value. So I would have taken the value of v final, squared it, and then taken the square root of all my algebra to solve for it. By that same process, I would end up with a positive or negative. I have lost the original information about the direction of that vector. So I have to use the context of the problem to determine positive or negative. That's something we just have to pay attention to when we do square roots. As we solve a couple of problems in class, I think it'll become clear how we're going to deal with that. But for now, I think that's a mathy enough lesson. I'm going to leave it at that, and we'll solve a couple of problems, okay? So.